You've probably heard a million times that plants get their food from the sun, but what does that actually mean? Today, we're going to crack a fundamental puzzle about photosynthesis, one that shows us where the energy for pretty much all life on Earth really truly comes from.
So this is the big question for today. When you think about making food, you think about ingredients, right? So is sunlight just another ingredient in a plant's recipe, kind of like flour in a cake? Or is it something else entirely? Let's dig in. Okay, so with any good mystery, you got to lay out all the clues on the table first. So let's do that. What actually goes into a plant and what comes out? If you could shrink down, way down, deep inside a plant's leaves, you'd find these tiny little green factories called chloroplasts. And this is where the magic happens. It's an incredible chemical reaction that takes really simple stuff and turns it into the very foundation of life.
So here it is, our official case file for this whole operation. The inputs, what goes in, are carbon dioxide from the air, water from the ground, and of course, sunlight. And what comes out the other end? Glucose, which is basically plant food. And hey, the very oxygen that we are breathing right now.
Now here's something wild. If you were to track every single atom, the carbons, the hydrogens, the oxygens, you'd see that nothing new is created and nothing is lost. They're just taken apart from the water and carbon dioxide and reassembled, like a giant game of molecular Legos.
And this is where the plot thickens. The atoms all add up, sure, but the food that gets made, that glucose, is packed with energy. I mean, that's what fuels the plant, and it's what fuels us when we eat it. So where did that energy pop up from? It definitely wasn't in the water or the carbon dioxide to begin with.
So how are we going to solve this thing? Well, believe it or not, our biggest clue is hiding in plain sight, on pretty much any food you buy at the grocery store.
Let's bring in our main detective tool, the calorie. We throw this word around all the time, but what is it really? It's super simple. It's just a unit we use to measure energy, specifically the energy our bodies can get from food.
For our investigation, the rule is easy. If something has calories, it's got usable energy. If it has 0 calories, well, you get it, it's got 0 energy. We're just going to follow the energy.
All right, detective hat is on. It's time to use our calorie tool on the inputs of photosynthesis. Let's see what the evidence tells us.
To check the energy of our starting materials, we can look at the nutrition label for something like sparkling water. And this is perfect. Why? Because it's got both of our main ingredients, water, H2O, and dissolved carbon dioxide, CO2, which is what makes the bubbles.
And what does the label say? Bam! A big, fat 0. This tells us crystal clear that neither water nor carbon dioxide provides our bodies with any usable energy. None.
And this chart just lays the whole mystery out, plain as day. On one side, you've got our starting matter, water and CO2, sitting there with 0 energy. On the other side, you've got the glucose that comes out, and its energy bar is way up there. How is that possible? There's a huge gap.
So the evidence is pointing to one inescapable conclusion. We start with matter that has no food energy, and we end up with matter that's full of food energy. That energy didn't just appear out of thin air. It had to come from somewhere. So if the energy didn't come from the water and it didn't come from the carbon dioxide, well, there's only one suspect left in our lineup, isn't there? It is time for the big reveal.
The logic here is just rock solid. Let's walk through it. 1. The output, glucose, definitely has energy. We know that. 2. The matter that went in, water and CO2, has 0 energy. We just proved that. So, 3. The energy must be coming from the only other input we haven't talked about yet.
And there it is. Sunlight. That's the source. It isn't just helping the reaction happen. Sunlight is the energy that gets captured and packed into those glucose molecules.
And this is such a cool way to think about it. The water and the carbon dioxide are the matter. They're the physical building blocks, like bricks and mortar. But the sunlight, that's the energy. It's the construction crew, the power that's needed to actually build something new with those blocks.
Okay, let's put all these pieces together and look at the complete solved picture of what's really going on here.
And here is the solved case file. Plants take in low-energy matter, carbon dioxide and water. They use this incredible external power source, sunlight, to fuel a chemical reaction. And that reaction pumps out 2 things, a waste product, oxygen, and the main event, a high-energy food, glucose, which is basically sunlight's energy stored inside a molecule.
So why is this so important? I mean, it's a huge deal. This one little chemical trick is how the raw, powerful energy from a star, our sun, gets converted into chemical energy that almost every living thing on this planet, including us, can use to survive. It's the foundation of our entire food web. And oh yeah, it also happens to create the very air we need to breathe.
It's an incredible thought, isn't it? When a plant makes food, it's essentially bottling sunlight. So when you eat a plant, or you eat an animal that ate a plant, what are you really running on? You're running on sunshine, captured from 93 million miles away.